Hello friends, so into the question, pulleys shown in the system are massless and frictionless. Threads are inextensible. The mass of block A, B and C are given as M1 2 kg, M2 4, M3 is 2.75 kg respectively. Calculate the acceleration of each block. So we are supposed to find out acceleration of each block. So we suppose that block A moves in upward direction with the acceleration A, and block B also moves in upward direction by acceleration B, and block C moves in the downward direction by acceleration C. And let us call this as string 1. There are two strings and this will be string number 2. So we assume that acceleration of block A is equal to A in upward direction acceleration of B of block B is B in upward direction, and finally the acceleration of C of block C is given as C and it is downward direction. So first of all we are going to find out the relationship between C, A and B. So for this we assume that the block A moves by a distance of XA, okay, and block B moves by a distance of XB, and block C will be moving as a result by a distance of XC. And in this case, suppose this is pulley P and this moves by a respective distance of XP, and this also is going to move by a distance of XP. So this, and if block A moves by a distance XB, so this pulley E will be moving respectively on the thread side by XB, and this will be also traveling upward by XB, and this will be helping us in order to find out the relationship between acceleration of A, B and C. Okay. So we see that if, and we can say that let block A moves by XA, block B moves by XB. So if block B moves by XB, we can say that pulley E will also move by XB, and to the left side it will be moving by XB, and the thread rather or string will be moving by XB, and to the right side the string will be also moving by XB. So pulley moves by XB both in upward direction and as a result of which we can say that pulley P will be also, let us suppose it moves by XP and it also moves by upward direction, and mass block C will move in the downward direction by xc. So we have two strings, string number 1 and string number 2. So we are going to write the respective distance equation, assuming that as the string is inextensible, we can say that the change in length, or we can say the sum of the change in length in the segment will be equal to 0. We can say that as the length of the strings are constant, the length of the string are constant, the sum of changes in the length length means segments should be 0. So we find for string 1 the equation, it is moving in upward direction. Let us take it as negative minus xa plus we are having minus of xp and plus this pulley will be making this, the slack in xp will be responsible of the slack in the pulley to the right side of, to the left side of xp. We can say that this will be equal to xp minus xb. This will be equal to 0. So from this equation we can clearly see that xp is equal to xa plus twice of xp. Let this be equation number 1. For string 2, okay, now we have xp minus of xp plus minus of xp, and xc is in downward direction, so plus xc is equal to 0. So from here we get xc is equal to twice of xp. Let us call this equation number 2, and substituting from equation 1 the value of xp in equation number 2. Okay. So from equation 1 into equation 2 we get xc is equal to twice of xa plus 4 times xb. Now if we double differentiate this equation we can get the acceleration. Okay, let this be equation number 3. Differentiating twice equation 3 we get acceleration of xc is c twice a plus 4 times b, and let this be equation number 4. Now we are going to draw the free body diagram of all the masses and including the pulleys. Okay. So if we draw the free body diagram of block A, this is A moving in upward direction by acceleration A, and there will be a tension T1, and M1G will be acting in downward direction. So from based on this we can write the equation as for block A, we can say that T1 minus M1G is equal to M1A. From here we can find out value of A. So A will be equal to T1 minus M1G divided by M1. And let this be question number 5. And similarly we find out for, we have the pulley E. Okay, so we draw for pulley E. So we have this T1 and this will also T1, and it is mass of B acting in downward direction by M to G, and let us say the T prime. Okay. So we can write for block B, you can see that now T prime will be equal to twice of T1. Okay, you can be right here, T prime will be equal to twice of T1. So we can directly put value, we get twice of T1 and minus M to G, it is moving in upward direction by acceleration of B, so we get M to B. From here we can find out the value of B. B will be equal to twice T1 minus M to G divided by M2. Let this be question number 6. And for pulley F, we can also draw the free body diagram. So this is pulley F, this was pulley E, and it is acting T1 tension. Let us suppose this is T2 as well as this is T2. Okay. So from here we can say for pulley F, we have T1 is equal to twice of T2. Let this be equation number. From here we can say that T2 is equal to T1 by 2. Let this be equation number 7. And last we have block number C. So this is C. In downward direction it is going to have M3G. Acceleration is given as C, and in upward direction is tension T2. So we can say for block C we have M3G minus T2 is equal to M3C, and we already found out the relationship between C, A and B. Okay, so we can say that from equation 4, C is equal to 2A plus 4B. So we substitute here, we get this as M3 G minus T2 is equal to M3 2A plus 4B. And let this be question number 8. Now we substitute the value of A from equation 5, B from equation 6, and T2 from equation 7 in equation 8. Okay, you can say that using equation 5, 6, 7 into equation 8. So we get this as m3g minus t1 by 2 is equal to m3. Okay, and we have 2 and value of a, that is t1 divided by m1 minus g, plus 4 times is b is twice t1 divided by m2 minus g. We open the bracket in the right side, we get this as twice t1 m3 by m1 minus twice m3 g plus 8 t1 m3 by m2 minus 4 m3 g, and this was equal to m3g minus t1 by 2. Now shifting all the t1 to one side and rest to the other side, we get this as minus t1 by 2 minus 2 t1 m3 by m1, and this is minus 8 t1 m3 by m2 is equal to minus 2 m3g minus 4 m3g, and from here it will be minus m3g. So if you cancel minus along the both sides, so this will be the equation. And next, now it is a quite simple equation. We take t1 as common and we get this as 1 by 2. Substituting all the values, we get 2 into 2.75 divided by 2 plus 8 into 2.75 divided by 4 is equal to, taking m3g as common, so we get 2.75, and within the bracket will be 2 plus 4 plus 1 multiplied by 9.8, that's the value of g. So this will, it's quite easy now. T1 is equal to, we get this as 2.75 into 7 into 9.8, and 2 cancels, 4 cancels this 2, and we get this as 8.75. Okay, and this will be coming as 2.56. So we can approximate that value of T1 can be approximate is equal to 22 newtons. So if we know value of T1, we can clearly find out value of T2. T2 is equal to T1 by 2. So it states that T2 is nothing but 11 Newton. Now we can also find out value of A. A will be equal to, okay, so we already have equation 5. Okay, so we can say that from equation 5, A is equal to 22 minus 2 into 9.8 divided by 12, not 12 but sorry 2. From here we can find out value of A, which is 1.2, and A can be approximately equal to 1 meter per second square. Now from equation 6, we have B, and B is equal to 2 into 22 minus 4 into 9.8 divided by 4. So this gives us B is equal to 1.2, and B can be approximately equal to, once again, 1 meter per second square. And we're supposed to find out actually all the accelerations. One second. Acceleration of C also. So we already know relationship between A, B and C. Okay, so we can say that from equation, what is that equation? Equation 4. We can say that from equation 4, C is equal to twice into 1 plus 4 into 1. So we get C is equal to a 6 meter per second square. So we got the acceleration of A, B and C. Thank you.